All right, we're in section 12.6 where we're going to look at surface area and volume of spheres. So spheres is the three-dimensional object of, like any type of basketball, baseball, volleyball, stuff like that. And like everything else, there is a specific formula for um, discovering what the surface area and the volume of a sphere is. So if you look at the surface area of a sphere, basically the formula is going to be 4 times pi times by r squared. All right, so and the volume of the sphere is 4/3 times it by pi times r cubed. So remember, just like when we talk about area of a circle, there's only one formula, and it's with respect to the radius. So again, if you have a diameter, or if they give you a diameter, you must convert it to a radius. So here, in this instance, we have a sphere where they want us to find the surface area and the volume. So first off, surface area, they give us the radius, which is great. So we're just going to plug it in. So it's 4 times it by pi, which I'll just use 3.14 to give me the approximation, times it by 8 squared, which is 64. So I got 64 times it by 3.14 times it by 4 gets us a surface area of 803.84, and then this is square inches. All right, to look at volume, it is going to be 4/3 times it by pi, which is 3.14, times it by 8 cubed, which is 512. So I got 512 times by 3.14 times it by 4/3. Let's see here. Yeah, I get a result of 2,143.57 cubic inches. Okay. So the one on the right gives you the diameter, so we have to convert it to a radius. So the radius in this case is 24 divided by 2, which is 12. So surface area is going to be 4 times it by 3.14 times it by 12 squared, which is 144. So I get 144 times it by 3.14 times it by 4. I get 1,808.64, and it was square feet. To find the volume of this one, we're going to get 4/3 times it by pi 3.14 times it by 12 to the third power, which gives me 1728. So 1728 times by 3.14 times it by 4/3. We get a result of 7,234.56, and that is cubic feet. All right, so here, what they give us is the circumference of a cross section of this circle, right? The cross section just so happens to be in the middle. So what we have to do here is, in order for us to find the surface area and the volume, we need to find this radius r. So in order to do that, they're telling us that the circumference is 48.78. We know that circumference of a circle with respect to the radius is 2 pi r. So we can say that 48.75 is going to be equal to 2 times 3.14 times it by r. So 2 times 3.14 gives me 6.28. What I'm going to do is take 48.75 and divide it by that 6.28. So I'll just go 6.28 here, 6.28 here. And I get a radius of about 7.76. Okay, so looking at surface area for this is going to be 4 times by 3.14 times it by 7.76 squared, which gets me 60.2176. So 60.2176 times by 3.14 times it by 4. I get a surface area in this situation, 756.33, and it was inches, so it's square inches. Looking at volume, we got 4/3 times it by 3.14 times it by 7.76 to the third power. And now that gives me 467 point, we'll say 29. So 467.29 times by 3.14 times it by 4/3. We get a result of 1,956.39 cubic inches. All right. So now here it says they want us to find the volume of the composite solid. So basically what it is if you look at the diagram on the left, it's a cylinder, and then on top of it is half a sphere. If you look at the um, diagram on the right, we have a cylinder, but then it looks like there is an opening on the bottom, which is half a sphere. So basically what you do is you got volume A here, you got volume B. What we're going to do is you're going to find the volume of A and add it to B in this situation. This cylinder, we'll call this A, this half sphere is B, and you're just going to take the volume of A and subtract it by the volume of B. So looking at the situation um, to the left, if we look at the cylinder, so using uh, the formulas from volume of a cylinder, it's going to be the area of the circle, which is pi. So we're just going to say 3.14 times it by r. Well, r in this case is 6, so 6 squared is 36, times it by the height, which is 13. Okay, then it's going to be added to the volume of the sphere. So now if you're going to go here, this is going to be 4/3 times it by 3.14 times it by 6 to the third, which is 216. But now remember, it's only half a circle, so whatever that result is, you're going to divide that by 2. So let's look at the volume of the cylinder first. So if I take 13 from the height, times it by 36, which was r squared, times it by 3.14, I get 1,469.52. All right, it gets added to, so now I got 216, which was r cubed, times it by 3.14, times it by 4/3. All right, I get 904.32, which is the volume of an entire sphere, but it's half of the sphere, so we divide it by 2. So now I get 452.16. So now I add those together, 452.16 plus 1469.52. I get 1,921.68, and it was cubic inches. So same idea to the right. To find the volume of this, I got to find the volume of the cylinder. So it's going to be pi, which is 3.14, times it by the radius squared, so it's 7 divided by 2, which is 3.5. 3.5 squared gives me 12.25. And then I got a height of 5.5. This gets subtracted by, this is now 4/3, times it by 3.14, times it by uh, 3.5 to the third power. So yeah, this gives me, this value here is 42.875. Kind of ran out of room. But again, this is half a sphere, so whatever this result is gets divided by 2. So looking at the volume of the cylinder, I get 5.5 times it by 12.25 times it by 3.14 for pi. So now I get 211.56. It gets subtracted by, so now I got the 42.875 times it by 3.14 times it by 4/3, which gives me 179.50, but now I got to take that and divide it by 2. So now I get something close to 89.75. So to find the volume of the composite, I'm going to take 211.56, subtract it by 89.75, and I get a total of 121.81. There's no units, so we'll call it cubic units. And that is being able to find surface area and volume of spheres. Hope this helps. Until next time.